Thank you for the introduction. It's my honor here. Actually, I'm an MD, but my job is to do the basic clinical research, especially the sleep research. So for the purpose of research, I developed the many hardware and software for the application of research. So today I'm very honored to share our recent experience in the application of cloud computing in the physical activity research. So the main sensor is the accelerometers, or also known as the G sensor. So now the G sensor can be packed in a very tiny package. For example, it is very small, but many sensors can sense the three direction, G-force or acceleration. So I think the most popular application is in the iPad or iPhone. You change the angle, the display can sense the change of the G and change the display. Also, it is applied in the hard disk. This is a picture acquired from a video in YouTube. It showed that the hard disk is falling from the table to the ground, and the sensor senses the change of the G and park the head to a safety zone. It's also used in many gaming devices, for example, the Wii. In terms of the biomedical research, and the G sensor is used in the exercise research. And for example, if you wear the G sensor in the wrist position, and it sends the X, Y, Z three-directional acceleration, and the three vector was summed in a vector magnitude, and then the change in the magnitude can reflect the change of the strength of the exercise. For example, if the exercise is very small exercise, such as sitting or standing, the change of the G force is very small. And if you are walking, the change of the G is moderate. And if you are running, the change of the G, the variation of the G is very large. And many relationships has been proved. It has been proved that the energy expenditure has a linear relationship with the change of the G signal. For example, this is a linear relationship, and this has been published in the medical journal. And my main research field is the sleep research. This is a recent paper published from my laboratory this year in the clinical neurophysiology. It describes how we use the G sensor. It detects the X, Y, Z three-directional G signal and summarized in the vector magnitude. And the magnitude can be performed with the phase Fourier transform, and the power is quantified here. So it shows that if one go into sleep, the power of the magnitude goes down to a very low state, and if the subject wake up, the power of the magnitude arises. And this change is very similar to that score with a standard method. This stage has been defined with a standard R&K sleep staging system. So you can see the G sensor signal has very accordance with the standard staging system. And also the G sensor can detect the signal of the heart. For example, if we put the G sensor on the chest near the heart, it can detect the vibration caused by the movement of the heart. And this has been known as the heart sound or this S1 means the first hot sound. This is the second hot sound. So this hot sound can be traditional. This is be detected by a microphone, and now we can use the G sensor to detect the similar signal. Besides the heart, it can also even detect the signal of respiration. So the sensor is put on the chest. When we inspire, or we inspire, the chest wall will move upward. So there will be a signal in the Z direction. So you can see the G sensor, the Z direction has a signal during respiration. So also the Y signal can sense the vibration of the heartbeat. So use a single sensor, we can simultaneously detect the respiration and heartbeat signal. So there are many biomedical applications use a sole G sensor. For example, I have mentioned the heart function, the respiration. Also, it can be detect the tremor of the hand or the posture of the body, and also the sleep and the exercise and others. And today I will demonstrate the real application that used in the sleep and exercise research. So the requirement is much simpler if the purpose is focused on sleep and research, but a special spec is the long-term monitoring. So the sleep and the exercise cannot be studied within very short period. Right? It should be studied for a very long period, for example, 1 or 2 weeks. So we must have the capacity to perform the long-term monitoring. And the solution is the sensor part is the G sensor, and the platform will be the cloud computing platform. So the cloud computing platform will collect data and analyze data in the internet cloud. So the user must wear the wireless sensor, the wireless G sensor, and the signal must be uploaded to the cloud, to the database in the internet cloud. And finally, the data will be displayed with the standard web browser, either in the iPad or the iPhone or in the PC. So the major specifications here is the G sensor. For the sleep research, the movement is very small. So we must have a very sensitive G sensor that can detect 1 mini G. But for the exercise part, the movement is much more larger. So we use the large scale or larger scale. For example, the 100 to 1,000 mini G for the exercise. So we choose a G sensor that can detect plus and minus 2G with a resolution of 12 bits that be sampled 100 times per second. And all the data will be uploaded to the internet and automatically. And for this part, we use the ultra low power wireless technology that I will introduce later. And the battery is the standard coin type CR2032 battery that can provide 200 milliampere hour. So the operation time is defined as 2 weeks. 14 days is around 336 hours. So the power current consumption can be calculated around 600 microampere, and it must be affordable. So this is a block diagram of the wireless Actimeter, and the coordinate is KY9. So the sensor will has a microcontroller that collect data from a 3-axis accelerometer, and the data will be stored in the non-volatile memory and will be uploaded with a low power radio frequency transceiver. And the upload will be carried out by a specially designed router that will receive the radio signal and upload to the internet cloud. So, so the G sensor I choose is a commercially available chip that provided by the Freescale company, or the code is MMA A442Q. So it can be operated with a voltage range around 2 volts, and the power consumption is very low, within the microampere range. The microcontroller is also the ultra low power grade MSP 430 provided by the Texas Instrument. And the memory we choose is the non-volatile ferroelectric RAM provided by the Rentron company. So this is also can be operated with a very low voltage range, around 2 volts, and the current is very small, within the microampere range. And the radio frequency we use is the so-called the ultra-low power grade. This is a module named Xenon 2C, provided by my laboratory. This module uses a chip, NRF24LE1, provided from the Nordic Semiconductor. So it is also operated with the 2 volts, and the current is within microampere to milliampere. So this is a circuit design. So this is a microcontroller, or this is a G sensor, or this is the RAM. For a better control of the firmware, so I write the firmware myself. So I can control every detail of the operation of the device. So this is a prototype of the wireless Actimeter. So you can see the battery occupy a relatively large space, and all the other component is relatively small. So this is a microcontroller. This is the RAM and accelerometer here. This is a RF transceiver. So this is the real spec of the device. It weighs around 14 grams, and it can be detect 3-axis acceleration with a sampling rate of 100 Hertz. It can last for 15 days. In order to upload the data to the cloud automatically, we also design a special router that it will automatically sense the signal from the sensor and upload the data to the internet complete automatically. So there are two rules of uploading. One is the GPRS, or the General Packet Radio Service. The other is the wired Ethernet. Okay, this is how we use the device. Usually, this device is applied beware in the width position, and this position has been proved to detect very accurately the energy expenditure of the human body. And the wirelessly range, the RF range is around 10 meters. Since this is a very low power RF, so the range is relatively short. And when the data is transmitted to the router, it will upload automatically. So the user can read the data with a pad. For example, this is an iPad, or you type an IP address, and you can see your data. So there are no manual operation. All the operation is automatic. So every time you go near the router, the data will be uploaded. And if you are far from the radio frequency range, you don't have to worry about the data loss, because the data will be temporarily stored in the RAM of the device. So next time you go close to the router, the data can be safely uploaded. So use this technique, we can very easily to collect data from many people. For example, this is data from one person for 7 days. So the data is collected every 10 seconds, produce one data point. So 7 days will gather many data. So we can, and all the data can be viewed with a browser, almost online or semi-online. So we can perform the continuous and online recording of the physical activity in the cloud server. And when the data was uploaded in the cloud server, we will perform some proper analysis of the data that can provide useful information for the sleep and exercise application. For example, this is a 24-hour data of the physical activity. So we can detect the time of sleep from this data, and also calculate the energy expenditure from all of the data. You use this calculation, or this calculation can be this can be provided from many previous studies. You use linear or nonlinear models. So this is a real display. You use a web browser, and one user has used this system for 3 days. So he entered this website, and the website will display the 3 days data. This is the first day, the second day, the third day, and for each day, the calorie of the day will be displayed. For example, for the first day, the user has exercise around 1,700 calories, and the sleep time is around only 5.1 hours. So the second day, the calorie is larger, and he also has a longer sleep time. In the future, the automatic service will be applied. For example, the cloud server can collect data, analyze data, and give some useful information to the user. For example, please work 1 hour and sleep 8 hours today. So the user can read the message from his cell phone and do some proper exercise and do more sleep. And if the system detects any abnormal condition, like it cannot handle, the message will be passed to the doctor or hospital to provide more advanced service to the user. Okay, so this is the last slide. So my conclusion is a fine integration of the sensor technology, information technology, and biomedical technology may provide useful healthcare service to people, especially the elderly. Okay, thank you very much.